Hey guys, how's it going? Now, I know I'm kind of late to the party, but I wanted to talk about Intel's Optane for just a few minutes because it's actually kind of a big deal. At the heart of Optane is 3D Crosspoint. Intel has branded their 3D Crosspoint based drives as Optane. 3D Crosspoint was a joint research project between Intel and Micron. Micron has their own Quantic storage that's also based on 3D Crosspoint. As a technology, 3D Crosspoint is being called the greatest revolution in storage technology in 30 years. Now, physically, 3D Crosspoint is a three-dimensional array of cells that are organized into levels with a sort of crisscross wire pattern connecting them, and these wires serve to both locate and manipulate each individual cell. The word crosspoint in 3D Crosspoint comes into play when the system is selecting a cell, because the cell that's selected is at the crosspoint of whatever two wires are activated. To write to a cell, 3D Crosspoint does what is called a bulk material property change. I can't figure out the physics that makes it work, but I do know that what it does is it changes the resistance of the cell, which then dictates the value stored in that cell. And since cells hold individual bits, that value is either a 1 or a 0. To read from a cell, the system sends a current through that cell via the wires that hold it at their crosspoint. And since it already knows the current, the voltage that it reads resulting from that can tell it what the resistance is of the cell itself, and since it knows the resistance, it will also know the value stored in this cell. An issue that we have with NAND is, well, it's twofold. First is the fact that NAND cells are organized into pages, which are then organized into blocks, and to write to even a single cell in NAND requires that the block be erased and then rewritten. The second part is the fact that anytime a block of NAND is erased, it's being shocked with an enormous charge of electricity, and this charge damages the block by a little tiny bit, but each time that you erase, it's damaging it a little bit more and a little bit more. And this lends itself to NAND's shorter lifespan when compared to mechanical drives. But a great thing about 3D Crosspoint is it's also twofold. First is the fact that we have much more granular control over individual cells in 3D Crosspoint. We can write to and erase and do whatever we want to a single cell without impacting any of the other cells nearby. And the second thing is that when you erase from a 3D Crosspoint drive or write to it, it's non-damaging. The bulk material property change doesn't damage the cell at all in any measurable way. And this, just like the shock to a NAND block damages the cell and limits the endurance, the harmlessness of a write cycle in 3D Crosspoint is a very large factor in 3D Crosspoint's impressive endurance. It's quoted at 1,000 times the endurance of NAND. A 256 gigabyte 3D Crosspoint based SSD could withstand 768 petabytes written. That's 768 million gigabytes written to it. And with proportionally larger SSDs, you would have proportionally longer lifetimes. With these numbers, if you wrote 10 gigabytes per day to your 256 gigabyte 3D Crosspoint SSD, it would take 210,000 years for you to reach that 768 petabyte theoretical limit. So for all intents and purposes of a typical user, 3D Crosspoint drives are essentially immortal. Because of its unique structure, 3D Crosspoint is incredibly dense. It's 10 times more dense than DRAM and has enormous potential to become even more dense with further development. And this suggests that we will see higher capacity RAM sticks based on 3D Crosspoint. The main reason DRAM hasn't had many legitimate challengers is speed, but not straight bits per second. System memory typically deals in small packets of information at a very high frequency, so bandwidth in and of itself is not nearly as important as latency, or how fast it can process requests for information. The P4800X is Intel's first Optane drive. It has latency 1,000 times faster than NAND and only about 10 times slower than DRAM. A factor of 10 is not negligible, and people who are still wanting the fastest RAM are still going to go for DDR4 or DDR5 when it becomes commercially available. But because it's more cost effective to make 3D Crosspoint, people who need more RAM capacity more than they need more RAM or higher RAM speeds are probably clawing at Intel trying to get their hands on 3D Crosspoint RAM. One last thing that makes 3D Crosspoint really cool. DRAM is volatile storage, which means it needs electricity to hold information, and when it loses that electricity, it loses the information. 3D Crosspoint is non-volatile, and it will keep that information forever, or until you delete it. Because of this, Intel is advertising Optane as a middleman between the system and a mechanical drive. It stores the most used files as it boots up the first time, and then every time afterwards it runs as if there's just any regular SSD in there, because the operating system is accessing most of its files from the Optane drive. For now, Intel is adamant about its use as a middleman, but in the future, this technology itself suggests the consolidation of SSDs and RAM, so we would only need one drive for the entire system. I love ITX systems and seeing how tightly we can cram high power components, so I love the idea of having a system where we only need one drive. For now, single drive systems are just a dream. They're just conjecture, because the P4800X retails for $1,500 and it's only 375 gigabytes. Thanks for taking the time to watch me sit in a chair, and I hope you learned something along the way. If you liked the video, give it a like. If not, do as you like. Don't forget to subscribe on your way out, and I will see you in the next video.